Alright peeps, let's get started. Quick partial fraction. I want you guys to try to expedite the process. So I'll have the teacher pause the video here in a second. I want you guys to use partial fractions and get to the answer as quickly as possible, skipping as many steps as possible, minimizing your algebra work, and finding an answer quickly. Okay? So 3, 2, 1, pause and give that a shot. Alright, so hopefully this is what you guys got. We can minimize our work now, 3 quick steps, doing a lot of the arithmetic in our head, hopefully. And then here's our simple answer. Here's the wonderful AP answer when they decide to douche it up a little bit. There we go, with the property of logs. Alright, so keep in mind what we were doing yesterday. We had this little twist, and the idea of the twist here is when we factored this denominator, if you guys recall, we had a repeat in our factor. So when we made our partial fractions, we had to have distinct partial fractions. And what that means is each denominator needed to be its own unique factor of the original polynomial. So this didn't cut it. Because of the repeat, we basically have the same fraction here. We need a distinct factor of the polynomial, which is why we needed a quantity squared, which is still a factor of the original polynomial. Since we've already done this problem, I've got a new one for you. So using our little twist idea, I want you guys to try this one all by your lonesome. Now, of course, you should check U-sub first. Clearly, U substitution is going to fail, so that we're going to dive into our new technique. This is still a partial fraction. This is still factors. You're going to have a repeat factor. So be very careful how you set this up. Use yesterday's example to help you, but I want you guys to solve this. Find me the antiderivative of this lovely little fraction here. All right? Give it a shot. You can pause the video, and then when you start it back up again, this pretty face will be there with all the answers. All right, go. How did it go? Hopefully well. Sure it went well. Not worried about it. So what do we need to be careful of? Distinct factors here. Here's our factoring. So we need a unique distinct factor over each value. You can put these in any order, it doesn't matter. And then your partial fraction algebra. Of course, we already have a common denominator, that's why we're leaving all this here. We need the missing piece. So this is missing an x and the x plus 2. This is just missing the x plus 2. This is just missing the x squared. And now it's just an algebra problem. Here's your 2 obvious choices, and then as we learned yesterday, we can pick any number we want. Let's pick the next easiest value, and then a little bit of arithmetic, a little bit of arithmetic. This requires a little bit of algebra with some more fractions, but we got there, -5/4, and then be very careful with your antiderivative. Obviously, I've avoided a couple steps here, but this is an ln. That is an ln. This is a power rule, not an ln. The antiderivative of 1 over x squared is -1 over x, or -7/2 over x. So that's why this term is not an ln. So far so good? Of course. You guys miss me. I can sense it through the video that you guys miss me. Just watch out for the glare, you know what I mean? Okay, so how bad could this get? Well, this is the last little wrinkle that you'll ever have to deal with. I will not put a problem like this on your exam Friday. However, you will need to understand the difference between the distinct factors and this situation here. So what's the problem here? Well, I've already factored this to save us some time. And instinct will tell you, well, just do what we've been doing, right? The procedure has been, I'll just throw a value over my first factor, and then I'll add another fraction and I'll do the same thing. Oh, this stinking smartboard. There we go. There we go. And we're back. However, this isn't going to work any more than our setup previously did when we repeated the same factors. Why doesn't this work? Well, because our division here isn't a single number over x squared plus 1. That's not how this division would work out. If I were to divide this, I'd be 1 degree separated. So if I'm going to separate this, I'm missing an entire degree on this division. Why? Well, this is not a factorable polynomial. I can't factor this. So the questions you guys asked on Friday, very good questions. You said, well, what do I do if I can't factor that piece? Well, here's the answer. This degree decides the degree of your numerator. If we're going to create a distinct partial fraction, and this quantity is being divided by this quantity, then I need 1 degree of separation to create my partial fraction. So this actually fails. This is not going to work. This is the wrong way to set this up. If I'm 1 degree away, then my first fraction is fine, some constant over x minus 2. But my second fraction, this is quadratic, this is x squared, so this should be a piece of linear information. If it's linear, there's 2 unknown variables, potentially. If it's linear, there's some constant next to our x term, and then there may be some constant by itself. And now we have a potential 1 degree numerator over a 2nd degree factor in the denominator. And now we've created correct algebraic partial fractions, which leaves us right back where we started. Now it's like every other partial fraction problem. If this was x squared minus 1, this wouldn't be an issue, because x squared minus 1 factors. This doesn't factor. So where are the pieces? I would really love to be able to break that into x plus 1, and then have a 2nd fraction, and then x minus 1, and a 2nd fraction. 1st degree, constant. 1st degree, constant. But I'm not able to do that. And since I can't do that, I have to account for both potential pieces existing in the numerator. Maybe they don't. Maybe it is just a number. Maybe this comes out to 0, but maybe it doesn't. So here are our distinct partial fractions, and now we're off doing the exact same procedure we had before. We need a common denominator. We have to multiply by the opposing denominator here, plus 1. And now we have a very tricky situation. We have a quantity, bx plus c, times the opposing denominator. And this is supposed to equal our original numerator. So this leaves us with quite the algebraic headache. However, you guys are up to it. AP Calc students, I'm not even worried about it. You guys can knock this out. So obviously, 2 is going to be a nice choice for us there. And then what you do from there is up to you. I challenge you guys to try to finish the rest of it after you plug in 2. Well, now what do we do? All right, so I'm going to ask the sub to pause the video one more time. And I want you guys to try to dive into the algebra here, see if you guys can solve for A, B, and C with your own algebraic creativity, and then finish the antiderivative. All right? All right, 3, 2, 1, go. You ran into some trouble, didn't you? In fact, we run into quite the nasty little headache here. This is the easy part. This is why I'm not going to put one of these on your test, because why would I waste a half hour of your time doing one integral? But as we set up this process and we start to solve, remember we can choose whatever we want. So 2 is the obvious choice, that got me A. And then I chose 0. That seemed a very reasonable choice because it eliminates B. And that allowed me to solve for C, and then I can choose whatever the flip I want. I chose 1, and I got 1. Substituting A, B, and C back into the problem, I get this lovely integral here, and oh my goodness, what do we do? This is easy enough, right? So this is fine. We're going to get negative 1 times the ln of x minus 2. But then all of a sudden, how in the world am I supposed to integrate this? It doesn't look very fun, does it? What did I do to you guys this time? Well, you won't have to deal with anything like this in my class, but this is actually a pretty simple solve because this is a common denominator between these two terms. So we can just split these up. I'll put x over x squared plus 1 and treat that as its own integral. And then I'll put 3 over x squared plus 1. And I'll treat that as its own integral. And wow, is this getting nasty, isn't it? This is a u sub. This is an arctan. And this was an ln. We are having fun. This is great. So this is already part of my answer, a negative ln of x minus 2. Well, this would be u. The derivative of that would be 2x. And I don't want a 2x. So I'd have a half in my u substitution. And then I will end up with 1 over u. So I'll have 1 half. It does end up being an ln again. But the half comes from u substitution, not from a partial fraction. And then I've got x squared plus 1. And then what's the piece that we never would have gotten had we not split this up, is this arctan piece. It's already a perfect match. If I take a 3 out, it's 1 over 1 plus, so it fits perfectly. So plus 3 inverse tangent of x, just a regular x in that position, plus c. How do you like that antiderivative right there? Woo-wee. Now you'll never have to do this. I won't put a problem like this on the next exam, but you do need to recognize the difference between this and x squared minus 1 versus, let's say we had x plus 1 quantity squared, which is when you need the distinct factors. So maybe that made sense, maybe it didn't, but hopefully the setup made sense. So let's try to summarize, okay? We've got all these techniques now, and here's what I want you guys to be able to recognize. This is a basic problem. This just factors, and you guys can dive right into your a over the first factor, b over the second factor. X plus 1, x minus 1, those are different. This has 2 common factors, but great, we can just u sub this. This would be u, this would be du, and I never have to worry about any of that common factor garbage. If there's a higher degree distinct factor, here's where I need the bx plus c. I have a over this, bx plus c over this. If we're top heavy, we end up in a long division situation. You guys already know that from Friday. And if, let's just say for instance, I was mean and I snuck this x in here, well now you need to break this up into distinct factors. My smart board's not happy with me today. B over x minus 1, c over x minus 1 quantity squared. What integrals will you actually have to finish on the exam? You'll have to finish one of these, you'll have to finish one of those. As far as these 2 techniques, all you'll need to be able to do is recognize them. How do I handle something like this versus something like this? I think that's more than reasonable. I'm a pretty fair guy. Mother Nature wasn't too fair to me, but it's fine. Try to stay on top of things. Okay, so a couple quick things before I convene with you guys. Round 1, round 2, round 3. What methods should I use? So we've exhausted all the methods now. You have your basic rules, your u sub. I want you guys to identify arctan as a separate sect of u subs. Of course, we got our uv vdus, and we have our partial fractions. When you're looking for a factorable denominator, of course it's a fraction problem that says partial fraction. So, I want you guys to look at round 1, round 2, and round 3. I think I can get them all on the board. And then again, I'm going to pause, and I'll come back. I want you guys to take just 5 quick minutes. All you guys are doing is writing down a strategy. Which technique is which? All right, so let me get out of the way first. And then 3, 2, 1, pause, and give these a shot. How did it go? See if you guys picked out the right strategy. Definitely a u sub, trapped function, its derivative is right there, or a version of it. Same power, this must be a parts problem, it's a product. And then this would not work as a u sub. You can't have e to the du power. There's no way to eliminate du, which is the goal of undoing the chain rule. So we have another parts problem there. This would be a tabular, so that you could cycle through those quickly. And then same thing here. The derivative of u is right there, or at least a version of it. You can't have du inside of cosine, so this must be a product rule, which means this must be a product rule, which means this must be a product rule. Probably going to do a tabular on this guy, and a tabular on this guy, so you guys can zip through it quickly. Don't forget the chains that are going to come out. And then on the bottom, these are the money makers here. Really make sure you understand the difference between these four. Factorable denominator, who cares? The derivative of this is right there. This is a u sub. Factorable denominator, and this is not a version of this derivative. This must be a partial fraction. This is addition. This is not factorable. This must be an arctan. Just need to make that a 1. You would say it's arc cotangent, really. And then the last one, this is a basic rule. I can split this up into x squared over negative x, and I can do 4 over negative x and simplify, and I have two very simple rules left, nothing complicated there. All right, one more round, and I will leave you guys for today. I know you guys are like, man, really, that's it? We can't, you want me to tell some puns? I'll do it. I'm not gonna do it. I'll save them for Tuesday. So here is a whole list of problems, and again, I don't want you doing any work on these. Don't antiderive any of these. We're just gonna glance. You know what? I forgot to change these. This is just me killing time in the video. So we already mentioned this one. Already mentioned this one. Already did this one. Already did this one. All right, how about just those? Let's talk strategy on all of these. All right, hopefully you guys can glance at this. This is already factored, but would this work as a u sub? You have to decide if you think that's if that's faster. I think we could quickly get to this. You'd have a -3 and a +2, and then you'd have your 6. Maybe it's worth doing a u sub for that one. Partial fraction will work, as we discovered on Friday. 2 degrees of separation, and this factors, partial fraction. Ooh, what's this? X squared minus 1. Is that top heavy? Ooh, it's just barely top heavy. This is a long divide, and then a partial fraction. What's this? Oh, it's almost a u sub, isn't it? What would we have to do here? The derivative of this would be 2x, and I could cut it by half, but I wouldn't have that. Or, I showed you guys how to do this before with that little twist. This we got to split up. This is actually the same thing as -x over x squared plus 1. That's a u sub plus 2 over x squared plus 1. That's an arctan. This is 2 in 1. You're welcome. And then what about these last two? Looks like this factors. U sub would not work. This is a long divide and a partial fraction. And it looks like this factors, and this is not the derivative of that. This is not a long divide. You would just jump right into a partial fraction here and be done. All right, that's it for me, and that's all you guys really have to deal with today. I don't have any more integrals for you. This is due to, oh, maybe not, any second, no, there we go. Oh, I had it for the, there we go. This is due tomorrow. You are not integrating any of these, so please don't spend 8.5 hours tonight doing the integrals. Some of these, one problem might take you 20, 30 minutes, so don't. All right, all you're doing is writing down the strategies that are in that little key on the right. All right, that's due Tuesday. You guys should all finish this before you leave and have no homework. Test is Friday. That's it. See you guys tomorrow.